Welcome back. Before building any model, you need to see your data file at least once, open it, see it thoroughly so that you can understand your data before building any model. So here I have opened my house.csv train CSV file. Why it is trained? Because it is training data. It has all this sale price in it, so that if you see, I have this sale price column here. So it has already the sale price. So my objective is to build a model which will predict the price of the house. This is my target variable, which will predict me the price of the house close to this target variable. And how I go about it? So first I will take the training data, I will do feature extraction, and I will feed into the machine learning model, which will predict me this y hat, that is sale price of the house. Then I will also take the data from the training file, which is already there, the sale price of the house by target variable. I will compare these two to see the error in the model, and I will then do some then I will refine my model to minimize the error. This is the basics. This is what is happening in machine learning. In using this model, we are interested in statistical relationships in which the relationship between variable is not perfect. So my task is not or any model is not going to predict the perfect price. It will just predict an approximate price very close to that price already existed. And why I am doing this? Because when some unseen data has come, which is only the description of the house, not the price, then I can this model will predict the price of the house and not the statistic price of the house, which is not that accurate price, but price somewhere very accurately approximate price. So let me go ahead with my Jupyter to explain you. Let me show you everything in Jupyter. Firstly, I need to import all the important packages from the Python which is required for my project. So it is nothing to worry that I have used so many lines of code here, because while doing one step at a time, I import the packages as per the requirement. So if you write one line once at a time, then you can end with 100 lines after some time. Then here I have imported the data file, and I just segregated the qualitative and quantitative columns separately. Qualitative columns are my numeric values, and quantitative columns my categorical values. And how do you know how many numeric columns or how many categorical variables are there? So you just need to print the data. I just import the file in the data frame, pandas data frame. You just need to put the info. You need to call the info function. It will show you all the details. Like you can see, my subclass is int, and ms joining is object, meaning ms joining is a categorical variable. Then I will go ahead and see whether I have any missing data or not, and I will do it with visualization because it's easy and it's more accurate. So here I have seen that this alley and pool QC, all these have more than 50% of rows empty. So after figuring out all this, then I will go with the I I will plot my y variable and see how it is distributed, because for regression model or any machine learning model, you need to pass normalized data. So you just need to do some pre-processing, some dimensional reductions to before passing the data to the model, I mean to that algorithm. So I see that my sale price is not normally distributed. I will show you what is the meaning of normal distributed. So here you can see how the normal distribution curves look like. It has a mean 0 and standard deviation 1. It's a smooth curve. You can see it is equally distributed on both the sides. So I will see the check whether my y variable is normally distributed or not. Then I just go ahead. I see that target variable is not normally distributed. So before before creating that my model, I need to normalize the y value. So here I am taking logarithm of it, because it will just because if you see the log curve over here, it is looks pretty much normally distributed price. Then I check the normality of all the variables, whether they are normally distributed, and I check it through the values, and then through the visualization, and I come to know that few of them are just normally distributed, but most of them are not. Then I did the same, and then I took my categorical variables. So far I'm working with numeric variables, but every machine learning algorithm, they just need numeric values, not any category. So I just go with my categorical variables, and I see how I check with whether they are null and how they are distributed using the blocks plot. Then I go ahead, I check how they impact on the sell price. I did everything in my visualizing, which because it helped me to build my model easily. Then I go ahead and I just encode my categorical predictors. Then I find the correlation among the data. Here if you see here, I just find the correlation of the data with sell price, how they are correlated. You see these are negatively correlated, and these are not at all, I mean less correlated, so I can ignore all these variables. Then if you go down, you see these are like neighborhood, overall quality, grid leaf area, they are highly positively correlated. So I just need to consider all these variables while building my model. Then I check correlation among the data, because the regression algorithms, they want to take the independent predictor variables, not the variables they are highly correlated with each other. So I use heat map to find that correlation among the data with predicted data with other predictors. So you see the color over here, it's dark, meaning they are highly positively correlated, blue meaning highly negatively correlated, and these dots show how if you see the quality prices with the sell price is highly positively correlated. So that's how I figure out the correlation among the data. Then I go ahead and did some then I so far I have encode all my categorical variables, so my data is in numeric form, and I created a pair plot to plot all the data with the sell price and see how they are related to sell price. You see the variation of the sell price with each variable, and then I decide which variable has high impact on the sell price. So after that I just go ahead and I try to find out, is there any clustering among the data. So here if you see, if I did some clustering among the data. So if I execute it, you can see, okay, some error is come. Okay, so I just here I find out is there any clustering exists in the data, and then I go ahead and build my model. Before building my model, I see that that logarithmic log is more appropriate for the for all the data, for the sale price, the target variable, for all the predicted variables. So here I have transformed the data accordingly, and I built my model in linear regression using that lasso regularization. And then I predict, I print the score, that is the accuracy of the model, and error. So I have created the model in not in only using one algorithm. I use couple of algorithms. I print their score and find out how if you see the score is, I print the score and see how they are so here I have built the model, and then I execute it, and I have printed error score and price errors sorry score and error. So you see my error is accuracy score is minus 6.15, then my error is less, it's 0.11. That means both the model it behaves almost in a similar way. Error 2 is like for my test data, and this is for my train data. So here I'm building, first I'm building a model, then I check that model accuracy. So when I build the model, I got that error is 0.11. When I check with my test data, that is when I checking that my model accuracy, I find it pretty nice. So I'm going to build my model in lasso. So this is how the machine learning or model actually builds. Actually most of the steps whatever I mention here is done through a pipeline. It's a sklearn function. We just need to construct that construct everything and then feed into that pipeline. This is all about this model. It's a little complex model, but there is no point to worry about it. In my course I'm going to explain everything in simpler steps, that at the end of the course you can build some model like this. So let me talk a few minutes on my course details. So see, in my course I'm going to cover all these important Python packages: NumPy, Matplotlib, Seabird, Pandas, and SciPy, Scikit, Keras, and TensorFlow. All these are used widely and almost in every application. Keras is particularly for ANN. So let's go ahead. I'll show you the structure of my course, and it is the structure of my course is, first I start with the basics of Python. Even though you know some coding, but it will brush up your knowledge. Then I will go with Python data structure, which is very important. Then we will talk about pandas. Then I will do the data manipulation and visualization using Matplotlib. Then I will talk about statistics in Python, because why did Python? Because you need to use that Python coding while building a model, so you need to understand the statistics in terms of Python so that it won't waste time. And then I will talk about this pre-processing data steps. It's the most important step in machine learning. So then I will talk about this machine learning modules. All these modules are explained here: the linear, multivariate regression, logistic regression, then unsupervised learning, classification, and SBM. And classification regression trees, I'm going to cover about random forest and boosting techniques. So and and last module I will talk about deep learning and network X. Network X is basically used for Facebook and Twitter, and deep learning is AI, and I will cover basics of deep learning because it's a very vast concept. But if you know basics, you can go ahead with the advanced concept. But it's a very advanced level machine learning. To know about AI, you should know about machine learning. All the algorithms, because they use this algorithm in each step to calculate or to refine the model. Every module follow with a demo project so that you can have some hands-on practice before going ahead, and at the end we have a capstone project. So this is all about my course details. So let me so now I come to the end of the session, and let me know if you have any queries or if you have any views on this course or on the topics so far I have covered, and thank you.